Hello and welcome to IoT Builders, a live stream where we discuss a range of topics on the Internet of Things, from embedded devices to cloud services, and all from an IoT Builder perspective. It is April 19, and this is episode 25 of our weekly live stream. My name is Alina Dima, and I'm a senior developer advocate in the AWS IoT service team. I'm joined here today by my colleague, Nanad. Hi, Nanad. How are you?
Hi, everybody. Yeah, feeling good. Glad to be here as usual Wednesdays. So yeah, I'm senior developer advocate for AWS IoT as well, part of the same team as Alina.
Yeah, and actually today we've got developer Steve, a senior developer advocate at Lumigo, with us. He's also an AWS community builder, and literally, as he defines himself, he's a geek who has a passion for all the things regarding technology, and he's always pushing himself to the limit. And he's here with us today, and we are going to talk about observability. We're going to talk about open telemetry. We're going to see some really nice IoT serverless solution that Steve has actually built. And let's get started. Hi, Steve.
Hello, thank you for having me. So amazing to be here. And speaking of observability, I'm in my observability ship right now, so it's a good topic and a good time. And I always love talking IoT things. Like, my biggest favorite is geekiest subject, alongside observability, of course.
This is great. I mean, I've been chatting to Steve for quite a long time, and it's actually really 1 a.m. where he is, and so it's really early in the morning. So thank you so much, Steve, for joining us from the future, from Thursday to Wednesday. Hello.
Oh, that's thanks for having me. And yeah, happy Thursday, everyone.
Yeah, we're still Wednesday here, and I think our colleagues from the US are in the morning, in the Wednesday morning. So yeah, it's really nice to have you. And observability is becoming more and more of a topic in the IoT ecosystem. Not that it wasn't a topic in the past, but I think with more devices, different kind of device properties, capabilities, and constraints, it's starting to get crucial to build observability at every step in the IoT applications. So, Steve, tell us a little bit. How do you see observability? Like, what do you think are the challenges of observability in an IoT ecosystem from your perspective? Because you are an expert in observability.
Great question. I think so. Well, two parts of this. The first part, as a developer, and I've been building apps for so many years now, and observability for me kind of solves that. Well, it solves that problem I've always had of finding needles in haystacks or errors in logs. Like, the amount of times I've had to go through logs on servers, and I still wake up in cold sweats during the night, just remembering those days. So, but I think in particular, now that we can do the being able to trace that error through a multiple of services or parts of the stack that I've deployed my application onto is priceless, because, well, I don't want to go through all those logs to be able to find that one error in all those different places. IoT observability starts to get a little bit trickier when you look at the capacity of these tiny little, here's one I prepared earlier, these tiny little boards. Obviously are quite limited still, although they're getting better. They're quite limited still in what they can do, what they can send, the amount of power they take to do all those things. But I think when you start to combine observability, particularly with edge devices, having these talk to an edge and then sort of send telemetry data back when they can, I think is getting really exciting, because it's so many possibilities of being able to trace in the field and beyond.
Yeah, no, absolutely. And I think it comes to be, what happens on the device, what should happen in the cloud, how does the aggregation happen, what kind of dashboards do you actually put on top to help operations teams investigate, and so on. So all these are really interesting aspects. And of course, it's also about creating a unified solution, right? So, having standard protocols implemented at every step to make sure that you can swap a dashboard for another, and your logging mechanism and your visualizations actually, can still be built from your log file, so the parsing still works. So yeah, I mean, maybe tell us a little bit about OpenTelemetry and how OpenTelemetry actually comes to support some of the challenges in the observability space.
Actually, OpenTelemetry is one of my other favorite topics. I've got a very long list of favorite topics. OpenTelemetry in particular, and I think you kind of hit the nail on the head there a bit, because OpenTelemetry creates that standard unified approach to how things are stored, how logs are stored, and then everything kind of built off the top of that. Like, it creates that foundational framework, that vendor neutral framework for fun things to be built on top of OpenTelemetry. Plus, I'm just going to do a shout out for the OpenTelemetry community, which is amazing in not only supporting a very growing ecosystem, but being able to support all those multiple of language frameworks and platforms to be able to do all the spans and telemetry collection and stuff like that. It's a mammoth effort from a community to normally support one library, but to be able to support multiple projects underneath that one umbrella, like, massive shout out to them, because that's a phenomenal effort. And actually, please contribute back to everyone that watching that wants to get involved. Like, they're always looking for new people.
Yeah, no, absolutely. I think what's interesting about OpenTelemetry and challenging at the same time is how to collect this data from the devices, right? I mean, I think this is maybe not so much an OpenTelemetry problem. Maybe it's a more generic problem on really small devices. But for OpenTelemetry, you need to have a special implemented data collector. And I think this is probably, one of the challenges. What do you think about that?
I totally agree. And there could be, I mean, depending what you're trying to do with these tiny little miraculous things, like if you're just turning like a switch on and off, or a light bulb, or something quite basic, it might be a lot different to a sensor, like an agriculture sensor sitting in a field somewhere, which might have a multiple of sensors, wind, moisture, soil sampling, that can then have a separate telemetry module that's sending data back alongside the one already sending back that sensor data, depending on connection too, of course. But again, it comes down to capacity of like what you're deploying and what it's capable of.
Right. I mean, I think I might be a little biased because I read some of the blogs that you wrote, and I've looked at some of the work that is out there for everybody to be seen. So I mean, some of my questions maybe I have already the answers for, but I think it's really interesting for the community to hear you talk. Maybe my question will be, IoT and serverless, right? Because I've seen you've done quite a lot of work in serverless and observability. And I think what many of the IoT engineers who mostly work on the device side are not really aware of is all these observability tools for serverless applications, which are very relevant in the IoT space as well, right? So maybe you can tell us what was the most interesting, serverless / IoT problem that you solved, that you looked at.
Actually, funny you should say that. And yes, I know you've read a couple of my things, but this one project, this one time. So last year, before reInvent was happening, Lamigo had we had a booth at reInvent, which is amazing. And I always love doing like fun demo projects that, demonstrate the product, but then at the same time, well, we can 3D print stuff and add a whole bunch of little circuit boards. Actually, one of these too. The issue I ran into, though, how you always have, as makers, as IoTists, we always have these like boards just laying around. Here's another one that I randomly picked up. We always have these little boards laying around, and with always the intention of using them on, fun projects or fun tinkery projects. Well, I decided to use an ESP32 Dev Kit C, which I picked up a number of years ago, and like they still work, but they're getting a little bit old now. Like the firmware's getting a bit on. And anyway, I ended up having a lot of troubles getting them to connect to anything. In fact, even this week when I was setting up the demo, that spoilers, I have a bit of a demo. setting up the demo ready to go for this live stream, and I couldn't get these things to connect to my Wi-Fi anymore because the SSL certificate in the firmware is so old now that they just won't connect. Anyway, I do have it connected because I managed to dig out an old Android device and put a SIM card in it, and it's connected to that. So I was able to get it connected. Also wanted to mention one of the things I did have, so I wasn't able to get this board to connect into, same reason, but it was last year, but I wasn't able to get the board to connect into the AWS IoT broker, which would have been that was my first go-to. So bit of a workaround, I ended up using a Lambda endpoint, which I can demonstrate. But one thing I really, really, really like, and I wanted to, I wanted to do another shout out to the team, was the IoT SQL. That is amazing. I loved using that. Like being able to query like the broker data coming through. That was so, I didn't even have to fire up Mosquito, which was like, that's what I would normally do. So yeah, it was actually cool to be able to use that again.
Yeah. I mean, I think from my perspective, I mean, I've done a lot of work on the cloud side and a lot of work on large scale of devices in my career, and I think one service that I've noticed recently that helps developers with MQTT problems and with data publishing, and also the TLS handshake and certificates and so on, is Device Advisor. And it's a really good service that I actually recommend developers out there to look at when they're trying to debug connectivity issues, because it really does help. I mean, especially with embedded devices, when you can have different versions of TLS libraries and different problems on the on the implementation side or on the stack side and so on. So that's actually really useful to have. And I mean, talking about the embedded side, I think Nenad probably has a bunch of anecdotes here, don't you, Nenad?
Yeah, definitely. I mean, the common one I think you experience it as well is like when the time is not set on a device, and then you want to go and do a TLS handshake, and then everything explodes. So yeah, typical one.
Yeah, actually, I had this bug on the first application that I actually brought to production. We had this bug. We were actually collecting data, and we were sending that data at a particular point of time every hour. Of course, the time that the time of the publish was actually, of course, implemented with a back-off mechanism so that not all devices are sending data at the same time. However, I think that we ran into this problem where there was throughout time, the devices were kind of going back in time. And at one point, it actually reached a situation where the time configured on the device was really wrong, and we started not getting the data properly anymore. That was the first thing we noticed, but actually later on, other problems started to occur. So yeah, having some sort of either a real-time clock or some implementation for keeping the time accurate is really important. These are funny problems.
Yeah, but this is why the observability is important from the very early stages of the project, right? To kind of like get those. But speaking about those, I read an article. I think, Alina, you sent this article over, which talks about quantum entanglement observability. So I'm not sure, what's what's up with that. And like, I know it's on the April 1st, it was published. I don't know if that's a joke or what it is.
I think
there's even a video.
Let's Steve tell us all about that.
No, that was an April Fool's post. I wanted to do something a bit quirky and a bit fun, and I mean, quantum entangled observability, it's probably going to be a thing one day, but it's, I mean, maybe a bit too soon, a little bit. Or is it? Because when we get into entanglement, we can go forward and backwards in time, or through different time zones, if you will. Hello from Thursday.
Exactly. So that's why I was wondering, probably this problem that we have with the time and TLS handshakes will not be there, so we will not observe it, right? Or maybe we will observe it nonstop. Yeah. I don't know how this would work.
Well, then it becomes a Schrodinger's cat with the cat in the box, and if you don't see the cat, you don't know what state it's in. It's quantum thought experiment.
Yeah, I
That's
mean,
cool.
jokes aside, I think this was really funny. So I read through this blog and I was like, oh, this is so cool. This is cool. And then at one point, after the first maybe 2-3 sentences, I was like, yeah, this must be a joke. What is Steve doing here? And then I realized that it was actually done for April's 1st. But I mean, still, like, Steve, I wanted to ask you, what do you think is going to be the next big thing, maybe in the observability space in IoT?
Quantum entangled IoT observability? No. That's a really good question.
I was expecting that.
I did see. That's a very, very long. Yeah, it's a very long word. There's probably an abbreviation somewhere. Actually, I've been following. Kind of curious to see what happens with the whole. So I think Raspberry Pi recently announced there's some new AI components being added to the new versions of Raspberry Pi. So I'd be interested to see, like, maybe the board itself can determine what telemetry is important to send and works out what what is mission critical and what isn't. Because if you're just sending, like, regular operational data through, maybe you don't want to send all that through in one go. So could be summarized, could be sent through. Like, I think that could be very interesting to see how that plays out. I think just sort of going back to one of your earlier points, one of the things I really like with OpenTelemetry and observability, particularly with IoT, is, I mean, those little boards, one of the biggest, my biggest challenges as a maker is working out what this board is doing. Because, like, beyond Arduino, your local Arduino terminal, you don't know what it's doing beyond that. And I think observability kind of helps mitigate that a bit. Alongside of Device Advisor, of course, which was actually really, really handy in working out that whole SSL handshake certificate thingy that I was running into. Because, like, with all the lights blinking and everything on the board, I don't know where it's going or what it's doing. So yeah, that was great to be able to sort of pick through logs and then see, the data came through once it was connected.
Yeah, I think Device Advisor is great. It definitely solves problems that you would encounter before you go to production. But of course, once your device fleet is in production, all the factors that are influencing your fleet are potentially different than whatever it is that you do in the lab. And I think from that point of view, observability needs to kick in. I mean, I know that a lot of development teams actually don't see observability as a day one must. So they bring a solution out there and they think, yeah, it's all fine. We've built the functional pieces, which of course are important, right? From a product perspective, you need to build features. Otherwise, nobody is going to buy whatever it is that you are trying to bring out there to the market. But these non-functionals, how they are regarded by the developer community sometimes and by the developers themselves, are really important. So I think it should be part of the definition of done. Of any feature that you are actually building, having these sort of metrics that help you figure out how much of your fleet is connected, for example. If your fleet disconnects, then you kind of look at what are the reasons for disconnecting. And sometimes all of this work is actually hard work, right? So of course tools can help you, and this is where it's really nice. But getting this level of observability throughout the ecosystem is really hard work, especially given the different types of devices, constrained, non-constrained, part of the same fleet, and so on. So I'm really curious about what will be the next thing.
Oh, I was just going to add, actually, that is a really good point, and one that as a maker, like, I always forget, because building like one little tracewire, buzzwire game is one thing, but deploying 100,000 of these little things out into the field and then trying to do over-the-air updates and try and work out what they're doing and making sure they're secure and everything. If you don't have those right tools in place from the start, from the get-go, like, you're in this situation then. no one wants to be here.
Yeah, exactly. Everybody likes the comfy environment, staying away from the fire. I mean, as a joke, I was giving a talk last week at the Node.js Congress, and I put this picture up where the actual journey of the developer through the IoT ecosystem is not sunshine and butterflies, but it's actually really just going like a ninja through a maze, which is full of fire and other things as well. So it's kind of how it is, really.
Yes.
But I mean,
Yeah.
let's go
Actually,
a little back to, go for it, Steve.
Oh, the week that I built out this demo, and most of it was done like I was literally 3D printing because I built 3 of them because Murphy's Law. Like I had my prototype device, which the only one I have left, because the other 2 got shipped overseas, over to the US. And so I had 3 of them that I was making in the span of a week just to get them shipped in time. And anyway, there was a lot of printing. Actually, I have some time lapses of the printing, and I printed them in 2 colors, which was in itself a whole feat. So yes.
Nice.
Wow. So tell us a little bit about this demo. Tell us a little bit about what you built, because I'm really curious to hear.
Can I share screen?
Yes, of course.
I have all the toys. All right, I think I'm gonna need my screen. I've got it down there we go. Yay, thank you. So this is the scope. So essentially, this is for those who haven't seen this yet or weren't at reInvent this year, last year. Oh, getting ahead of myself. Or behind, or entangled. One of the 3. But yeah, this is a buzzwire game. So Lamigo does distributed tracing, open telemetry, based on OpenTelemetry. For those that hadn't already guessed. So I thought, actually, I'm going to step back a slide. Hang on, because there's a fun slide that kind of explains it. There we go. So when we were coming up with like fun ideas for the booth, and I love IoT stuff, like I use it everywhere. My whole house is full of this stuff. I put 2 and 2 together plus IoT and got Tracewire game. So this is one of those like navigate the maze sort of games. And so the scope for it, of course, was all good adventures start with a really good scope. I had the board that I was figuring out which board to use. I went for just an ESP like Wi-Fi board because we had devices there to be able to connect it to. And for those that saw my social media this week, I rummaged through, when you keep those, like every cable you ever get for this one random like IoT project. Anyway, I finally used some cables from my box of spare cables on this project. Stripped out some copper cables and a few other things to be able to build them. Loads of so much 3D printing. I'll show you the time lapse in a sec, but I was prototyping the print while I was designing the sketch and trying to, get the devices connected and build the back end all at the same time. It was an entangled approach, if you will. Also, fun fact, in PowerPoint, you can actually take your STL files and animate them. Look at that. Anyway, for anyone that hadn't tried it yet, literally in PowerPoint, just drag it and drop it in, and then you can do all sorts of fancy animations with it. Pretty cool. You might notice here too, the STL that I designed for the casing on it is in 2 colors, because I have a printer that can do 2 colors at the same time. Literally, to do that, if for anyone that hasn't tried it yet, it is as hard as it sounds, because normally with a 3D printer, you got to make sure the nozzles like all lined up and everything with the board and everything's level. That's actually twice as hard with 2 nozzles at once. And it's actually 2 models being printed on top of each other at the same time, which in itself is, it's kind of a pain. I don't recommend it, but when it works, it turns out really well. Anyway, of course, I have a broker set up. Well, I kind of swapped that out a little bit with Lambda, but and I'm using DynamoDB as the database, and I did build 3 of them, so there is that as well. That's the board I used, and then so this is basically the architecture that we used for the event last year. I've stripped things down a little bit now because I'm just kind of using it in light demo mode. But I mean, once you get the data into DynamoDB, you can kind of do anything you want with it, which is pretty easy. I'm just going to show you didn't play. This is the time-lapse printing. I use Octoprint to time-lapse this. I totally need a better printer too. This is, this is done all right, but I need a new printer. And you can see the dual nozzles there, the 2 colors at once. This is like one of the printers.
I had this situation with this dual color as well when I was also printing, and there was 2 different type of PLAs, and then the one was getting harder quicker than the other, and at the end it just became like a mess. So I have a couple of questions to see how you did this, but we can come back to that afterwards.
The dual printing, that is a whole, that is an art form. Like, I don't know how many, I've seen one printer that can do 4 colors at once, which is I don't know. That's a step too far for me.
You know, I hate
That's why
printers in general, like
Anyway,
the normal paper printers. But when it comes to 3D, I hate them 3 times much than like a normal printer. So I mean, yeah.
Yep. Well, especially with those really big prints too. Like the main body, like I printed 3 main bodies for this, and the main body. Wait, I'm going to switch to camera mode. There we go. I've got a little overhead camera set up. Oh, that's my hand.
Oh,
Next to me. So this is my prototype case. Like
looks good.
it turned out it wasn't as good as the ones I sent overseas. And for scale, that's my hand. This took 14 hours to print. So, and that was like the rushed version. The full version took 18 hours. And those last 2 hours, I was literally watching every layer go down because nothing could go wrong. Anyway, fun times.
Cool
When it works, it's great.
Yeah.
So should we? I think that was it for my slides. Should we do a demo? Oh, let's do a demo.
Yes, we'd love to see it.
There we go. All right. So this is currently, the red light's on. It's currently connected. The way this sketch works, I won't step through all of it. Oh, yeah, I took my username and password out for my Wi-Fi. This is good. Thank you, past self. Essentially, what I ended up having to do, I've got the AWS root certificate in there because the board to do an SSL connection I'm using a Lambda URL, and so it had to validate total hacking workaround, but it works. Oh, hopefully it's going to work. It should work. But yeah, they can validate the SSL, do the SSL handshake properly. And then essentially the way the game works itself. There we go. When I push this button on, there we go. There's a red light that's going on the side. Whoops, I just triggered the game. Go what? Oh, I'm gonna wait for it to send. Oh, now it's got stage fright. There we go. So when there's a red light on the side that's just gone on, you can kind of see it reflecting off the case, which means the game's active. So when that happens, like there's a timer running, and so the idea is to try and navigate the maze as quickly as possible without. And I just touched it. When the contact happens with those 2 wires, then it knows the game's ended, and so it classifies that as a game end type 2. There's 2 different game end types. One is me pushing the button again, which ends the game, or 2 is with the wires touch. It takes is it milliseconds or microseconds? Milliseconds. It takes the milliseconds and then sends that over to Lambda, and then from there it like basically processes it. And so the response back then is sending me back a hash ID from the entry going into the DynamoDB, and it's also recorded the time. So wire touch game end. And then that sends it over to the endpoint, which I should be able to see. Oh, I should have grabbed that ID. Yeah, while that's loading, I'll go grab that. Oh, I think it worked. There we go there. So this is the entry here, and then it's got an end time of, 13 seconds is really high. But the Lambda basically receives that as part of the URL call, and then is able to like transform that into seconds, which I can then use as a leaderboard. So be able to work out who had the fastest time. And then I've got a couple extra fields in there just to record people's names and stuff so that you can get a bit of a leaderboard going. And the best part I love about this is in the OpenTelemetry call, I can see the data coming through and then each service that it's then calling, just like that. So there's the get coming through, and then the Lambda being called, and then all the data that came through as part of that. So the game type, the amount of microseconds, and then the database being like storing everything. Which is great when it all works.
Nice.
The Lambda invocation is synchronous, right? From the is it a synchronous invocation or is it asynchronous? It's synchronous, right?
Synchronous, yes.
Okay. I see.
The other good thing with this, 2 is, I'm able to also track down some errors. Actually, this was one I was having earlier because I decided I would rewrite some of the scripts before the live stream, because that's what you do when you like to live dangerously.
Perfect.
And of course, we're getting some runtime errors. So I went with the existing one, which is fine. But I'm able to see, like, I already know what the errors are. It's because I upgraded the Node version and I was using SDK2, and now I upgraded the Node and now it's using SDK3. So anyway, I decided to just run with the script that I knew worked.
Beautiful. So where are these, the categorization of issues based, type error or runtime? Where's that coming from?
That's coming from, I've got Lamigo hooked up to my AWS, and it's basically scanning the serverless errors as they come through, and then I'm able to pick through the log, trace through each of the microservices that are attached to that, or the distributed services rather, through the distributed services and see where those errors are being thrown. In this case, like, I already know that it's like it's Lambda.
Cool.
Yeah, I already knew. I kind of know what the problem is here. Yeah, I was running out of time before the show, and I was like, I need to get the demo working. Yeah, there we go. It's totally a Node thing. Anyway, I need to rewrite some code.
Yeah, it's pretty cool.
So can you show us I was still really curious about the duration of Lambda executions. Like, do you have, is that consistent? Or do you have sometimes spikes in duration or something weird anywhere there? Okay.
On this screen, so there's a couple showing as having cold starts, which we actually got some really good write-ups, and I should probably fix that. But we've got some good write-ups on how to mitigate that. I mean, this is kind of my prototype testy playing one. But yeah, there's some ways to be able to mitigate the cold starts and make things load a lot quicker. Some great techniques. Actually, shout out to Jan too, because Jan writes some really great articles for us on the Lamigo blog. Actually, on his blog too. I'm covering a whole range of really cool serverless topics, including a lot of different cold methods to be able to fix cold starts. And help things load a lot easier, a lot smoother, and obviously a lot faster as well. When it's on a hacky demo script.
Pretty cool.
Yeah, it's really nice.
The thing I like with this screen though is, it's especially handy when you've got a lot more. Actually, I'm going to switch to demo mode and see if it's. There we go. You're able to pick through and see. There we go. Wow, look at that one. This is this is the demo environment, but essentially it can show a lot easier in a more distributed trace environment what type of things you'd be expecting to see in various parts of your environment. So you can see there's errors, there's all sorts of different cold starts that you'd be able to trace through. That's not an error one. But from that screen, when you've got a lot more sort of lambdas running, you're able to more easily see through the different services, like where the errors are appearing in what services, and like how, if there's any latency issues, if there's errors being thrown. Sometimes there's data, downstream data errors that are caused by improper fields being set in a service like 3 services ago. And again, like as a dev, I don't want to pick through needles in haystack logs to be able to find that. So being able to trace those errors through becomes a lot easier, a lot quicker when using OpenTelemetry to be able to find that sort of stuff.
Yeah, I mean, can you see also if the Lambda function, for example, failed and then it was retried automatically by the Lambda service? Because I think Lambda is a little evil this way, isn't it? So there are times when out of the box, without you configuring it, the default is like, I think it's true retries for asynchronous functions that just happen without you actually being involved. So it's quite interesting. I'm curious if you can actually see that here.
Even when you have the queues as well, the retries in the queues, so that when things get placed into a backup queue to be reprocessed or try to be reprocessed, like being able to spot that sort of stuff and trace that through the different services makes it a lot easier to be able to find this sort of stuff. So you're not picking through a multitude of logs or I'm going to say back in my day. Oh, that makes me sound old. But going into actual servers to do tail on a log to try and find that one thing that is hiding somewhere. Like those days are gone. Yay!
Yeah, no, absolutely. I mean, I think if you have to do this even on 10 devices, to actually even if you have possibilities to do secure tunneling onto the devices and so on, you have to do it on more than just one device, one time or a few times for debugging purposes. I think it's a total pain. So ideally, nobody should actually have to go through that.
Speaking about
just today. Oh, you go.
No, go. I wanted to ask something, but go first.
I was just going to say we also have this tracing now for containers, not only on ECS, and I've got a workshop next week, actually with AWS partner people, if anyone wants to come. But then also just today we announced Kubernetes for EKS, the tracer to be able to do the same sort of thing, but except serverless, but obviously in the amazing world of Kubernetes. If anyone wants to check that out. Literally the blog post was published 3 hours ago. There you go.
Yeah, I remember on Kubernetes back in the days. I was working with Zipkin and that kind of stuff. I'm wondering, is Zipkin still, the main distributed tracing tool that people use? How does that work now that we jumped on that?
No, good question. Yes, it is still around. Actually, we have some guides talking about how to do that, like how that works and why you would want to do it, the pros, the cons, etc. And even deploying your own services or rolling your own and then trying to run sort of your own infrastructure alongside, or ways to trace and monitor and etc. But yes, that is still around.
Okay.
I guess the main thing to look at with any of this sort of stuff is ultimately, I always have the Friday rule for any of this sort of stuff. To ask that particular question, but also all the hackathons I've done over the years, should we build our thing? Should we build our thing on that? And I always Friday rule. It's if you're halfway through, if you're playing Minecraft or playing some online game, or you're having a quiet drink somewhere, and you get that call or you get that alert on your phone saying the stack's down, and we've all been there. I know I have. On a Friday night, if you can support it while you're doing that, then it is the right thing to use.
Okay, yeah. I think that's a good rule of thumb, nevertheless.
Yeah, I remember something funny. I remember from one of my previous projects. I mean, I was actually working on a project where literally we had a lot of devices being provisioned overnight and coming online, but lots of devices. So imagine something like 500,000 in 4 or 4.5 hours, something like this happening every night. So what we actually built there was also a mechanism to send us emails. It was kind of built on top of the indexing service. So we had some clever querying mechanism to see, hey, is it an error here? Is it an error there? Is it an error in another place? And based on this query, when something was going wrong, it would just kind of ship us an email and also ship us other emails with reports, let's say every, 3 hours or so. But of course, it's not something that you'd leave in place forever. but it's just that fiery period of like maybe 2-3 days when heavy provisionings are happening. So yeah, I don't miss those times when I was checking my email, bam.
Well, the good thing with Lamigo too is we have alerts, so you can actually set up like a custom alert to aggregate that, or only trigger with certain error types, or even certain services that you put either an AWS tag on or a Lamigo tag on. So you can sort of specifically narrow it down and say, oh, you can also get it. You don't have to get an email. You can get it in a Slack channel or in Teams or wherever it is that you do your monitoring and your team resolving.
Okay, so you can make changes on a Friday safely, and then exit.
You can totally do. Oh, I should switch to my. I'll do my this is fine scene now. Wait, I'll switch over to. There we go. Yeah, because every time things never go wrong on a Friday at all ever.
Yeah, depending like how much you like challenge and drama, you can choose to do that.
Yeah.
But speaking about the old days, I wanted to ask you this question: like, what was your first computer, and then what was your first IoT board? Like, I'm curious to know about this. You mentioned a couple of times old days, and I want to ask him this.
Oh, I'm totally going to give away my age now. Actually, I'm just going to mention here too. Like, I'm sure people follow Darko on social media, and his retro computer collection is like, it blows my mind. Just the other day, he had like this big like portable. I think it was the laptop, like ergonomically like lifting it around. It was massive. Anyway, my first computer wasn't one of those. Was an Atari 800 XL. So this had a 5.5-inch disc, like it was like that big. And I taught myself BASIC on it. It was QBasic. That's right.
QBasic.
He probably has one in his collection, I'm sure. First board. My first board was an Arduino Yun, back before the ESP32s. I say back before, but this was in 2014, which doesn't feel that long ago. Oh, it was nearly 10 years ago. Wow, that went quick. Anyway, yeah, the Arduino Yun. I think I paid like $70 Australian for it, and then the same year, the like ESP8266s came out, and they were what, $4 or $5 I think Australian, maybe like $3 American. And they like both did the same thing. They both connected to the Wi-Fi. The Arduino Uno had the biggest personality I have ever seen in an IoT board, because there was two sides to it. You had the Arduino side, a JSON bridge, and then you had OpenWRT running as like the Wi-Fi connection. And the JSON bridge had so much latency in it that like I ended up having to write my own storage system to get data in and out of it. So fun times. We've come a long way.
Fortunately.
Yes.
So was this your most favorite IoT project?
Well, yeah, that's a tricky one. My most favorite. Oh, I got two I'm going to talk about. One is, so this is one of the other big prints that I've done. Actually, I keynoted with this a few years ago at Next Comp, and managed to fly this to North America just to get. Oh yeah, this is a really big light bulb. It actually still has the LEDs inside it too. But I was using a Cat M1 narrowband device to basically interact with just through Broker to be able to talk to it, which was kind of fun. But the one that really blows my mind, oops, hopefully it makes it a few more miles. The project that really blows my mind is the backscatter Wi-Fi devices. So I've been following this research from the University of Washington for a number of years. You can 3D print devices on a normal consumer printer that don't need any electronics but can produce a Wi-Fi signal, and it's just insanely cool. So totally right. There's some great videos floating around if anyone wants to see it. But essentially, it uses a conductive plastic a layer of conductive plastic to create an antenna, and then a plate of conductive plastic hitting the antenna basically creates a Wi-Fi spike, and you can detect the Wi-Fi spike. So it needs motion, but insanely cool.
Amazing. That
Cool
sounds
stuff.
amazing. Yeah, I think we talked about this, like, hopefully one day, I mean, as of now, we cannot print silicon, the integrated chips, but like hopefully one day we can start printing those. And then, you come to this point, it's like, okay, I download all the files from the internet and I have a machine that can actually produce. So you get like just-in-time manufacturing. I'm looking forward to that day. If that day comes, unless we get annihilated by AI or something.
Well, it's still, one of the things I love. I've got I bought one of those Oculus Quests when they came out, and one of the things I really love that I can do with that is there's an app called Gravity Sketch, and you can take your 3D prints and like design them in VR, and then like take them off there and 3D print them. Like, the future is now. How cool is that? Like, so many possibilities.
Excellent. Yeah, the only bugging thing as I have as of now is like, I really like your setup, like your station. Can you teleport yourself to other places? Like, how does that work?
I can. Let me just switch some screens around so it's a bit quicker, because yeah. This is the problem in orbit. Like, I need more screens in more fun places. Anyway, all right, here we go. I can. Good thing you asked that. So this scene, literally, this scene's brand new. This is the first time it's ever been used on a live stream, and I decided this week. Oh, I'm telling everyone my secret. Yes, I'm using OBS. This is the other one. This is the other one I did this week. Hasn't been used anywhere before. This is a space train.
Oh, cool.
Yeah, it's kind of fun. I had to slow it down. I always test these with colleagues. So my Lamigoian colleagues, I got into a call the other day with this one, and it was running a lot faster. And she was like, "It's making me motion sick." So I had to slow it down a little bit. What else have we got? Actually, let's go with, where did I put it? Not the Jedi. Oh, there we go. So sometimes I'm with my good friend, Wookiee friend here, which for licensing reasons, this is my Wookiee friend Sal Kaza. This is a very famous scene from a movie.
He's doing all of the things behind the scenes, like, responding to comments and changing your scenes and all that stuff. Okay, that's pretty cool.
Yeah, and he's writing your cloud formation templates as well.
Nice.
Oh yeah, I need to get back to that. It's so close to deploy. That was one of the other things I was doing before the live stream. Oh yeah.
So now I get all of those comments that are like gibberish and so forth. So that's where they're coming from. Okay. Yeah, I see. Okay.
And of course, this is another famous scene with a certain astromech behind me. Where is it? There we go. Can never line that up right. Which also has a hyperspace function.
Oh, wow.
As well. What else we got? Oh, and then there's dinosaurs. You can have fun with the live stream. And for those that did see, I am just using OBS. Is my favorite. This is what happens if you don't observe your apps. You see, you don't know what's running around behind the scenes. There's a really big dinosaur that comes out in a minute. Any minute now. Oh, and then of course I am in the southern hemisphere, so sometimes there we go. Velociraptors run off. There'll be another one in a minute. Any second now. Then of course I am in the southern hemisphere, which means for everyone I'm sometimes a little bit the wrong way around. I don't think I showed you this one, International Space Station appearance. But yeah, I was since doing a lot of
does your
live
teleportation
streaming
device your teleportation device, does it have to do with quantum entanglement, or like how does it work?
Yes. Actually, sometimes I even sometimes I even appear in VR in so there's another scene. I have this series called Quick Bites I do from the Lamigo lab. And so sometimes I'll be in real life with a VR headset on in the screen behind me, and then avatar me from VR appearing like in my seat here. Sometimes I obviously don't have that running today, which is weird because I'm using an app called it's 2 a.m. and the name eludes me. Immersed VR. And so in Immersed, I'm able to capture the screen into OBS, and I have a chroma key, like literally an entire green sphere around me with a whole bunch of screens, which is all I can see. But everyone can I can take that and put me here and have IRL me behind me. Anyway, that gets a bit. Yeah, it's a lot of layering for these.
So do you want to show us some of the tricks?
You want to see the? Yeah, I can show you. Hang on, let me grab. So the other part to this. So that's my OBS. The other part with this, the part that's actually the hardest is the audio. So I use Farrago, and this one is Audio Hijack. Actually, I just got a new version of Farrago today because I just realized they brought out a new version. Where's the camera? There we go. So OBS essentially works on a whole bunch of different layers. So I can do, for example, that's my IoT layer just there, and I can just turn them on and off as I need to. Oh, actually, is that missing? Oh, I think it is. No, that's not it. I never remember what's in these. Oh, there it is. Get it right. There we go. So that is just a transparent. It's just a PNG like loaded in as a image layer in sources for the scene, and I can just switch those on and off. So these are animated chroma keyed emojis that I sometimes throw around. Oh, actually, all right, line this up. I'll do the audio one first. Hang on, let me get the music. So with the audio setup I've got running here, got my microphone running here and a couple filters running just to clean up my sound a little bit. And that runs into virtual audio music and sounds into this as well. So for example, this is when I do like a fancy trick. But I can also put music in too. Oh, this is going out to YouTube, isn't it? I don't think I can play any of these. Pretty sure I can't. Okay, well, picture if you will, I'm playing music right now. I don't want to get the video taken off.
Nice.
Yeah, picture if you will. I'm going to go to the water.
We
room
believe
right
you.
now. Oops, not the Star Wars corridor. There we go. But sometimes you just got to dance a little bit, right? And so this goes better with music. But anyway. And each one of these is just one layer. So like I can turn, Confused Travolta on, for example, or I could even Rickroll everybody.
Amazing setup, man. Amazing setup.
Anyway, it just keeps evolving. Like I add a little bit to it, and a few weeks later something else will come to me, and like you add one more bit to it, and next minute you've got all this. So many scenes. So much fun.
So what's the learning curve really with OBS to be able to do all these cool things? I mean, would you say it's like a day or a week or a month or continuous with a steep initial learning curve?
Continuous. Yeah, I started in 2020 when we all went virtual. Yeah, before the 2020 when everything most things went virtual, years before. So, and it's just been a constant learning process of especially the early days. And I'm running this on a Mac. OBS on a Mac back in 2020 was horrible. I used to watch my CPU go up to 200% of CPU running constantly when I was doing this. Now it's really, really good. And that's just testament to, again, the open source community behind it. They've so much work into making it so much better over the past few years that can now do this sort of stuff and My fan doesn't even kick in. It's great.
Yeah, no, I think it's amazing. I think it's really cool. I don't know about you, Nenad, what your experience with OBS is, but mine is like I've started literally maybe like half a year ago. So I'm just really at the very basic level. So I'm always amazed and curious to actually learn when I'm seeing all this cool stuff happening.
Yeah.
So thanks for sharing, Steve.
Oh, it's okay. Well, one thing I should mention, the key, because I'm green screening, I'm the keying everything. The biggest challenge is just getting enough light into your scene and also having a nice like flat background. So spoilers, I've actually got an entire room to be able to do this in. Like I can stand up and walk around, and there's a wall. There it is. And then, just to give away more secrets, I can do this as well.
Invisibility cloak. I love it.
What a invisibility cloak. So this is relatively new for this. I painted an entire room green. I used to use a drop curtain, like a 2-meter drop curtain behind me, and now it's on the back of my chair. So that's how I was doing like the whole like chair not being there thing. So I actually can like lean on it, but can't really tell.
Cool. I think we are slowly running out of time. I don't know if anything else you wanted to mention.
I have a question. Actually, I have a riddle. You weren't expecting this riddle, but I've decided I have a riddle.
Yes.
All right, ready for everyone's head to explode. If Pinocchio says his nose is growing and it's not growing, what happens?
He's lying. I don't know.
I don't know. It has to do something with the Schrodinger's cat or with the quantum entanglement, definitely.
Actually, I mean, there's no answer to this, but I mean, my answer to this is it's in a quantum state. It's growing and not growing at the same time. So, yeah.
Yeah, exactly.
It answers
everything. Maybe we should do a separate episode only on like quantum computing and that part of physics. Maybe we should do that.
Quantum is so cool. I can't wait until IoT. Because I actually can't wait until like IoT devices start going quantum. I'm sure it's only a matter of time. That's going to be weirdly, insanely cool.
Excellent.
Yeah, so as the last thing that I wanted to ask you, Steve, is probably very short. I've seen, I don't remember where I've seen this, but you've got a bunch of jokes that you are somehow, in your presentations. You've got them up your sleeve somewhere, don't you? Tell us a bit about that.
I do. I was just trying to think of one. No, I do. I actually have a few of them. How do fallen trees check for errors? Via log files. Wait, I need my sound effect. Where's my little scene?
Yeah, you can tell us also the one with dark forest. There was one with a dark forest, I think.
Dark forest. The other one I have is actually security joke. This is my favorite security joke. Is why did the vulnerability get tired? Like sleepy. Because it ran somewhere. There we go.
Okay.
Always actually one more. What do you call a singing computer? Adele. There we go.
Okay.
You keep that collection somewhere, like on the internet? We can check it out.
Yeah.
Oh, actually, there's a few. There is actually a few developer joke repositories that I submit. Like I've submitted a few of these to from time to time. I actually don't remember all of them all at once, and I feel there's some really good ones that I can't. Yeah. Anyway, it's 2 a.m. But anyway, yes, I do have them floating around. I actually tweet them sometimes too, just
nice.
Because.
Cool.
Oh,
yeah.
Actually, you want one more before we go? Do we have time? One more?
Yeah.
Why couldn't the HTML list be trusted? Because there were lies everywhere. LIs everywhere.
I like.
Anyway.
All right.
Now, also important to note is these are open source, so please share them around.
Nice.
Yeah.
Cool.
Thank you very much, Steve. We're kind of getting to the end of our time today. Yeah, it was really insightful. Thank you so much. Thank you for the demo. And for the people who are watching us, see you next week. And until then, enjoy your morning, your afternoon, or your future.
Sleep.
Like Steve. Yeah, get some sleep, Steve. All right. Thank you very much. This was all for IoT Builders today. Bye.